This is Dr. Matt Murphy, Senior Lecturer and Director of Education in the Department of Mechanical, Materials and Aerospace Engineering at the University of Liverpool. And you are listening to the Academy's Developing Practice podcast.
Hello, in this University of Liverpool Learning and Teaching Conference special, we meet with Dr. Matt Murphy, Senior Lecturer and Director of Education in the Department of Mechanical, Materials and Aerospace Engineering at the University of Liverpool. We discuss how he's developed enhanced employability opportunities for students through the authentic industry-led projects. We hope you enjoy.
Matt, we're really pleased to be speaking with you today, and we're really delighted to talk to you about how you have developed an enhanced employability for students through authentic industry-led projects. But before we get going, and we like to do this on every podcast, could you just give us a little bit about your background and how you arrived at your position that you're in today at Liverpool?
Well, I first arrived at the University of Liverpool in 1988 as a fresh-faced, wide-eyed 19-year-old undergraduate. And I did my first degree in metallurgy and materials science, and then straight into a PhD where I worked on the 3D printing of metals. And then after that, I had about a 10-year postdoctoral research career in advanced manufacturing, 3D printing, and similar technology, both in the university and a brief stint working in industry, which I guess is a pretty standard trajectory for an engineering academic. But then in about 2004, I stopped and changed course entirely. I left my technical research behind and I started to focus on education, teaching and learning. And I took a job as the manager of one of the Higher Education Academy subject centres. The one for what Liverpool University had hosted two, I don't know if you know this, but one in archaeology and classics, and the one that I led, which was the one for materials science. So I then became a teaching and scholarship academic in around 2007. And I'm now Senior Lecturer and Director of Education in the Department of Mechanical, Materials and Aerospace Engineering.
Wow. So just tell me then, what happened in 2004? Why the shift?
Yeah, I'm not sure whether I should admit it. I'm surrounded by colleagues who start their research discipline in their PhD and are so passionate and engaged with it that they keep it up for their whole life. I'll be honest, in 2004, I realized I was getting bored doing that subject, researching that technology. I'd done a lot of it by that point, and I wanted to change. I don't think I was cut out for someone that worked in a very small field of technology for their entire career. And to be honest, I never thought that I would make the switch into education. I thought I'd probably move into a different area of technology, but the opportunity to join that subject centre came up. The interviewer, Professor Peter Goodhue, who's now retired, said I was a wild card interviewee. I didn't have any of the right experience, but I did okay on the day and I got the job. And I think it was actually a really good move. It was a very rewarding time, actually, the subject centre network. When I joined, it was just before the formation of the HA. It was still called the Learning and Teaching Support Network in those days. So it's exciting times, and things changed a lot in the following years as the HA was established. And it was really enjoying, actually, because my role was to support all the materials departments in the country. So I got to visit almost everywhere and give talks and look around and meet colleagues. So it's actually a really exciting job to have. Spent a lot of time on trains.
Yeah, I can imagine. But you always came back to Liverpool then. So there was obviously a big draw after you were a student to stay. Yeah.
Again, I read somewhere that Liverpool is the city that most students stay in after graduation. And I know a lot of people that did. And when I look around my colleagues on graduation to see the gowns they've got on, many of those were Liverpool PhDs, so they stayed. Yeah, I mean, the city's got a lot of great things going for it. And now I've got two teenage girls. I'm probably here for life.
Yeah, the roots are down now.
Fantastic. And today, Matt, we're going to talk about your recent Learning, Teaching and Student Experience Award and your Sir Alistair Pilkington Award. So many congratulations on those. So those awards are based on the work that you've been doing with students in the School of Engineering. So it'd be great if you could start by telling us a little bit about that kind of module development that you've been a part of.
Well, first of all, thanks very much. I should point out, of course, that these are team awards. So I have to acknowledge the enormous contribution of my academic colleagues and also the technical staff in the school. My work was on capstone projects and none of that would be possible without the technicians. I hope we can perhaps come back round to that later on. Well, before I talk about the actual work that we've done on those capstone project modules, I'd like to set the scene a little bit by going back to late 1990s in Cambridge, Massachusetts, and MIT. They're obviously one of the leading engineering schools in the world. And around that time, they decided to survey the main employers of their graduates. So that's the great and the good of American engineering and global engineering. And they asked them one pretty simple question, and it was, are our graduates any good? And the answer they got from almost every employer was, no, I'm afraid they're not. They know a lot, they're extremely intelligent, but they can't do much. That was a surprise to MIT, and it raised a few alarms with them. It just happened at the same time, a group of 3 Swedish universities, Chalmers, KTH and Linköping, did the same thing, carried out the same exercise with their key employers, and they got exactly the same answer. So clearly there was a problem with engineering education, particularly in higher education, and how well it was meeting the needs of industry and more broadly society as a whole. So those 4 universities, MIT and the 3 Swedish universities, formed the CDIO Initiative, a collaboration to develop engineering programs that focused not just on the acquisition of scientific knowledge, the kind of drift that engineering education had followed in the preceding 25, 30 years, not only to focus on the acquisition of knowledge, but equally on the development of skills, attitudes, and experience that their graduates would need for their lives and their careers ahead. We joined, the University of Liverpool joined in 2003, that collaboration. We were the 12th university to join. And today, last look on the website this morning, there are 170 partners in 35 countries. So the problem discovered by MIT and Chalmers in 2000 still exists today, and a lot of engineering education, basically all the leading engineering schools in the world, agree with that problem and are trying to do something about it. So the CDIO Initiative works with global employers, professional bodies, and other engineering organizations to try and define the ideal set of graduate attributes. And that's now codified in what's called the CDIO syllabus. I'm going to provide you with a link to these things actually afterwards, which go alongside the podcast. So you can find all these online. That syllabus goes to the X point, it's basically a set of learning outcomes. It goes to the X point, X point, X point, X level and runs to 24 pages of A4. It's a very detailed description of the ideal graduate. And then, so we also then work with each other to develop programs and educational approaches that will allow us to deliver that ambitious graduate output specification. So, and to do that, we've created the CDIO standards, which I'll also link to. And they're a set of 16 guiding principles for effective engineering education. Some of those cover program design, program delivery, some cover tools, resources, and facilities, and others cover staff development. So it's quite a comprehensive set of principles. And embedded within those is one common feature for all CDIO programs across all those partners. And that's the capstone project, which I think we're here to talk about today mainly. In our department here at Liverpool, the capstone projects are worth 45 credits. They're 2-year projects that run across years 3 and 4 for our integrated master's students only. And all of these projects are team-based, in which students design, build, install, test, drive, fly, ride, real engineering products and systems. So what we try and do with these projects is to replicate professional engineering practice, but on campus in a university setting as closely as we can. And the purpose of them is to provide students with an opportunity to develop, rehearse, and prove vital skills and attributes. So you've probably seen the most photogenic of our capstone projects, have you? Which are the
Orion.
Global, the Arion, which is
Arion,
our velocity, the fastest bike in the world, I like to call it. It looks like an egg on wheels, doesn't look much like a bike. So the Arion has broken 6 British records and 3 world land speed records in the Nevada desert. So that's obviously a very high profile project for us for numerous reasons. The other one that most people have heard of is Formula Student, where a group of about 15 students designs, builds a single seat race car and flies around Silverstone in it in the University Grand Prix against about 100 other universities from all over the world. It's called Formula Student.
Yeah, I've seen that. I've been in the garage where they've been building that. It's fascinating. Really, really interesting.
I mean, those two projects really give a snapshot into what our students can achieve. It's astonishing to me, given the kind of education I had as an undergraduate, that our students get the chance to do this. But the fact that they can go from basically a second year who has very little experience of practical engineering, and in 2 years do those things, it's astonishing.
Yeah. Have we had any students that have managed to find their way into Formula One or any of the formulas? Do you know?
We have. Well, I mean, Formula One, sports automotive is some small. There's not many opportunities,
no.
And our students are up against the best in Europe, in the world, against those. So it's hard to get those jobs anyway. We have had some success in that, but I think it would be, and this is a message I have to share with our students, is that it doesn't really matter what the subject of your capstone is. If you're building a car or building a bike, that doesn't prepare you to go and work in the building of cars or the building of bikes. Capstones are all about the skills you develop while you're doing those amazing things. And those skills equip you, we hope, for almost any job in engineering and in other sectors. I mean, I think later on, perhaps we'll visit some of the skills learning outcomes associated with these projects. And we'll see that they're the ingredients for almost every job application I've ever seen. They're much more transferable, let's say.
I like this conversation because it shows where Matt's head is in terms of speed and Formula One. I was really interested to hear about the example that you included in your presentation around the tomato farm because my head goes to food, in Zanzibar. Can you tell us about that and the impact that had?
It's a really interesting story, actually. So one of the main industries on Zanzibar, which is an island just off Tanzania, is tomato farming. And it's not done by rich global corporations with all the money and facilities you might need, but it's done by farming cooperatives, families and villages that cooperate to farm tomatoes and to take them to market. And vital to their success is refrigerating their crop. The problem is the electricity supply on Zanzibar relies on a subsea cable from Tanzania. And that's a very unreliable connection. So there's frequent blackouts, the refrigeration systems fail and the crops are spoiled. So really the farmers on Zanzibar need their own off-grid, sustainable, reliable power. And one possible solution is, of course, wind power. So in this project, we've teamed up with Siemens Gamesa Renewable Energy. They're a Spanish company, but we're working with the office in Aalborg in Denmark. And we're designing a wind turbine to be installed for a group of these farmers in Zanzibar in 12 months' time from now. We're halfway through the project. So the students are having to get to grips with the science and technology of wind. They're not taught that in their first 2 years. So this is in the project. They have to up their knowledge and expertise in those areas. And then they have to become turbine designers. And as I say, when they start, they're just second years. They've done a few lecture courses, maybe some small projects, but nothing like this. So it's a very steep learning curve.
Why do the students need to design a turbine? Why can't we just pick one up and a pre-designed turbine and put it in the place?
Oh, an excellent question, and one that I asked them in their vivas. You can buy one of these for about $4,000.
Yeah.
You can. But the ones that you buy are designed to be used, let's say in Northern Europe country, where there's good access to technology, where they can be maintained, they can be supported. I mean, and $4,000's not nothing. These tomato farmers, that's a lot of money. And they're not designed to be used on a windy hillside in rural Africa. So what we're designing is a low cost, low maintenance, easy install turbine for those people in that place. So in actual, just for your interest, we didn't want to jump straight in and design the Zanzibar turbine. We've nearly finished our first turbine, halfway through the project. We wanted a practice run to see what we didn't know really, right, and to try it. And what we've done, I don't know if you've heard of, well, you've probably heard of Peloton, the cycling community interest company in Liverpool. Well, they've got a BMX track in Everton Park called The Box. To jump sometimes. It's a proper one of these things.
Track.
They do half-term things for kids and they provide free school meals and all those things. Really good charity. I know Danny who runs that. And they've got a little shipping container, which is their workshop on that site. And it's off-grid. They run it off batteries. It's not really good enough. So we're building our first trial turbine for them, and it's going to be installed in Everton Park. It's about to start manufacturing. So that's a brilliant thing. So our students have been up there. They've even started volunteering for the charity and doing stuff as well. So it's been fantastic. But what we're going to do is take that one designed for Everton, and then next year's project is about converting that into one that's suitable for a windy African hillside. So they're going to be saying, right, those blades, which are made of composite and a complex shape, we can't have that. They're going to turn into something much more simple. We're going to be putting a hinge in it, so that, and a series of guy ropes so the farmers can tilt it down to do regular maintenance. So the answer to the question is, it's for them.
Yeah.
And supervision in these projects is technical, of course, helping them get to grips with the engineering required. But it's also much more akin to sports coaching. There's a team of 11 students on this project doing difficult things under severe pressure, and we have to almost have our arms around their shoulders to give them the confidence and the reassurance that they will be able to do it in 2 years. And you can imagine in the first years, this is a steep change for them. They've never worked like this before. Most of our projects are supervised just by academics. But in this wind power project with Siemens, our students are being supervised by 4 professional engineers working for Siemens in Denmark. It's a dream come true for the academic supervisor. My life's much easier on this project than it is on some others, because the students have 2 hours. The 11 students are split into 3 sub-teams. One of the electrical systems, one's the blades and everything at the top of the tower of the turbine, and one's the tower itself. And each of those sub-teams is supervised by a professional engineer at Siemens. And they have 2 hours supervision a week with them. And then we all get together for 1 hour a week, the whole team, all the students, all the engineers at Siemens, those 3, plus their boss, who's a senior manager there, and me, and our technicians. And we have a big meeting every week. So it's a really well-run, well-coordinated, and well-supervised project. But the secret to it is those students, the 3 that are supervising the sub-teams, are all alumni of ours. They're class of 2018. So they haven't been out of university long. And they did capstones themselves. 2 of them did the velocipede. They were the team leaders for that. And another one was the team leader for the Formula student team. So they know exactly what these students are going through, both technically and emotionally and personal and professional development wise. So they're really the perfect people to not only supervise, but also to be mentors, role models even, to bring the students on and help them develop into future professionals.
I guess there's a difference here though, isn't there? Because those previous capstone projects, they weren't directly affecting the income of a farmer, someone's real life. So this seems like higher stakes to me.
It certainly is. And that's one of the developments that we've made in recent years, is introducing these authentic real world projects that have a real impact. So there are others. I've spoken to you about the big sporting projects, the international competitions. And I've spoken about one project that has a real world impact, the one in Zanzibar, working with the farmers. Other projects, we've been working with the equine surgeons at Lea Hurst. We've finished that project, and that was completed last year. When a horse is coming around from general anaesthetic, it's quite a difficult engineering challenge to manage a ton of a horse as it's unsteady on its feet. And the vets have tried these rope-assisted systems, but they realized that they needed to be properly engineered. So our students worked hand in hand with practicing vets, about a dozen over at Lea Hurst for 2 years, to understand the processes and to build engineered solutions to help manage the horse as it comes around. And those are in use in 2 rooms, recovery rooms at Lea Hurst right now. We've also worked with the National Nuclear Laboratory to develop robots for hazardous nuclear environments. So these robots are vital to go in and explore, take samples and map and prepare for the decommissioning. So we've been running that project for many years now, probably about 8 years, because it's an ongoing challenge. And we've designed many different robots, again, with the help of National Nuclear Laboratory. We've worked with Jaguar Land Rover to help follow the flow of raw material as it comes from the foundry into the one door of Jaguar Land Rover to the finished car. They need to follow that exact piece of metal and know where it ends up. So our students developed a laser marking system to mark and track that material, and that's in use. A version of it is in use at JLR in Halewood now. And there are other stories, but so I think we won those teaching awards because we've moved away from global competition, although we still keep those because they're exciting and high profile. But what we've done is we've got rid of some of the more academically constructed projects, the ones that we dreamt up just to give the students a project, and we've replaced them with authentic projects with external partners. I mentioned that they're authentic projects, and I think from hearing of what they are, that's clear. They're real industrial projects. So our assessments in the capstones are, I'll call them authentic. They're the kind of instruments they would use in professional practice. So they'll give a group presentation about progress on their project. They'll then write a group report. They'll then be interviewed one-on-one. And then there's a performance evaluation mark. So each semester, those 4 instruments come in. We're trying to make those as close as possible to professional practice. And let's say the report that the Siemens students write will be slightly different in form than the one that the Formula students will write, or the NNL. They can choose the structure, the content and nature of the progress report to suit either their partner or their project. We might be straying into negotiated assessment a little bit. I'm not quite sure we're there yet. Given the work that Simon Thompson's just been doing, I know, but there's flexibility in assessment, if you like. So, but we try to make it authentic. So that's perhaps a point I did miss out.
Yeah, I think that's really exciting in terms of the student experience, isn't it? So thinking about our Liverpool graduate attributes and what we're aiming at, that exciting student experience must really have a massive impact on our students in terms of their confidence, in terms of their global citizenship, working with academics who are at the top of their fields, but also working with professionals in the field. That must be really, really inspiring for them.
It really is. I mean, perhaps this is a good chance just for me to read you a few quotes I've harvested from my EVISIS forms recently. One was from a student who worked on the National Nuclear Laboratory project, and I'll read it out directly. Capstones give real life projects that are exactly the kind of projects engineers do in the real world. These projects are exciting, and I was nervous to be involved in a real project that would affect the real world. But this motivated me to get stuck in straight away. So the students really do acknowledge the fact, actually, I'm actually taking a step outside my university life. I'm doing something real for the first time. And I think that does make them nervous and excited. And I think they're two of the perfect, that creates a perfect situation for learning on these projects. To be nervous and scared is perfect. On a similar theme, I think a student quoted on this year's EVISIS surveys, for the first time, I feel like I'm becoming an engineer. And what that says is they can really realize this is no longer an academic problem that I've constructed. It's something real, and they're working with real people. And another one is we've produced work this year to a high standard, partly due to the pressure of weekly meetings with Siemens Gamesa, where our work is scrutinized in detail. So they're now not just preparing work for my eyes, they're preparing work for professional engineers. It adds a pressure to them, which again, really does drive engagement and attainment, I think. And I really like this last one as well. I strongly believe that I've learned more from this project in a single year than I have done in the rest of my course combined.
Wow.
That's a student perspective on it. I mean, it's not true, but what it is they feel like they've learned more because they're doing engineering. Sometimes we forget when they sign up as year 13 students, they're passionate about doing engineering, to secure a sustainable future for the planet, to improve the quality of human life on it. And then with our courses that they have to, of course, go through, we do quite a good job of squashing that enthusiasm and ambition in the first 2 years. And one of the beauties about capstone projects is it allows it to flourish again. They remember why they signed up in the first place. And I hope it renews their commitment to the discipline, I think.
Some of those projects are fascinating to me because I'm into motor racing. I'm also into nuclear power. I'm sort of a little bit obsessed with it. So out of all these industry partners, what has their feedback been? What have they been saying about the experience of having students on their projects?
I mean, yeah, over the last few years, in our efforts to, firstly, to get industrially focused problems for our students to work on, we've obviously been speaking to a lot more companies, and I think there's two levels we need to view these authentic industrial projects at. There's those where the company sets the problem, gives students some support, advice, guidance, and background technology as they go through, and they revisit at the end to review the final outcomes. That's one level, and we have a whole catalogue of projects in that column. The one we've been discussing about the wind power for the tomato farmers with Siemens is another level. That project, as I described, has got the industry partners actually supervising week to week. These are professional engineers on the payroll of Siemens who are giving us 3 to 4 hours a week, every week, for 2 years. It's a massive ask. So the question about why do they do it, what do they get out of it, is different for those two groups. So for the first group, I think the industrial engineers have a sense of responsibility to the discipline. They recognise that the students' education will be better if they've got real-world projects to work on in partnership with them. So it's their contribution to the next generation of professional engineers. I also think what they do is they give us problems that they've been wanting to get around to for ages, but haven't because of the pressures of day-to-day work. And you never know, this bunch of novice engineers, these students might come up with a solution that works. And I've given you a couple of examples where we have developed things that have gone straight into practice. So with the project, do something useful for the company as well. And the third thing it gives those companies in that first column is it gives them an extended look at our students. It's like a 2-year interview, basically, that really can get into the detail and identify key students. And many of our students do go on to work for the companies that they did their capstone with.
Yeah, I was going to ask that. I would have thought, having worked in those environments with those people, that it just must open so many doors for them.
It does. I mean, it's a feature of all CDIO programs that they have these capstone projects. And employers, because CDIO has been going since 2000, all employers now know that CDIO is there, and they know our graduates are distinctive, actually, slightly more practical, more capable, more well-rounded than perhaps students that have had more of a traditional scientific education. So they start to seek them out.
Right. So when you say well-rounded, what skills are we talking about? I take it it's like the soft skills of dealing with pressure, or project management, maybe organizing people development skills, I guess.
Absolutely. I mean, I've got a list here. I'm going to spin through them. Before I do that, I'm going to take you tat about your use of the phrase soft skills.
Okay, go on.
One of my pet hates. Skills are skills and they're all important.
Fair enough. I will take that on the chin.
In preparation for today, I revisited my module specification for the capstone. There's a long list of what I would call personal and professional skills in there. Teamwork and collaboration. I work with each other, academics, technicians, industry, creative problem solving, end user consultation, the tomato farmers or the vets. International remote collaboration using modern digital tools. We've used about 10 different pieces of remote collaboration software. It's driving me mad, but it's been really useful for the students. Interpersonal communication with each other, arguing, negotiating, persuading, those kind of difficult things to teach. We can only provide students opportunities to develop them. We can't teach them. Formal communications, project planning and workload allocation, as you said, Matt, project management and reporting. And here's a key feature. The students tend to use the project management and reporting processes of the company they work with. So our Siemens students are using the corporate procedures. Every meeting is run exactly as an internal meeting would be run at Siemens. They use the same software, they write the same reports in the same format. So they really are getting a training here almost. Agenda setting and meetings, technical record keeping, data management, peer and self-performance evaluation, very important. Global citizenship, international mobility with the Siemens project. The students will be spending a week in Denmark next academic year on a study visit. And then the last bullet point I've got in my list are also things that are really tough to achieve in a HE. Confidence, resilience, adaptability, willingness to take risks. These are all things that the students develop through the challenge of these projects. So I think all our capstones deliver some of these. I think the Siemens one probably gets closest to the full list because they're learning these things in an industrial setting, even though they're on campus. It's almost like they're doing a job. And I'm going to introduce now one of my new hot topics. I think So many of these learning outcomes that I've just described are more normally associated with an internship, a year's placement. I think our students, through close involvement with professional engineers on these projects, are getting many of these learning outcomes, but by staying on campus. And I hope we're moving towards developing the concept of an outternship, which I think is very important for many reasons.
So tell us what you mean about that. What's an outternship?
Well, that long list of personal and professional development learning outcomes I just recited are all things that you would normally expect students to develop whilst on placement somewhere in the industrial setting, working with fellow professional engineers on real stuff. But they're getting that on campus by this close involvement with Siemens, the remote supervision and working on their projects with them. So I think one of the problems with internships for engineers is there's about 100,000 undergraduate engineers in the country at the moment, and they all want a placement, either a full year or a summer. There's just not enough. So this might be a way of giving more students that kind of learning experience without them having to add a year to their program, without them having to go through an extremely competitive recruitment process to get these placements. So it can extend it, make it more convenient, make it cheaper, make it easier for the company. They don't have to produce, they don't have to produce an employee record, find the salary and all those things. So I think there's many benefits that we're just starting to scratch the surface of. I don't really know where we're going with it. It seems like I really like to think I coined the term outternship myself. So I did a Google search. I could find the word, but not in this context. So have you two come across anything like this? The word outternship being used in this setting?
No, not me. But I do find it really interesting that the fact that we're hopefully coming to the end of a pandemic has probably opened this concept up a little bit more, because the more companies and the more people who are switched on to working remotely, having meetings through online technologies, should mean that this becomes a greater possibility than it would have been before the pandemic.
Yeah, that's a really interesting aspect to it. Actually, we set up the Siemens project knowing they'd have remote supervision because the Siemens engineers are in Denmark before we'd even heard of the pandemic. So that was always going to be over Teams. But you're right. The fact that everyone is so now used to doing what we're doing right now does mean it opens up this opportunity. In fact, we're so pleased with how the Siemens project has gone. We're halfway through that we're introducing 2 other projects on exactly the same model next year, both in Merseyside, one in Runcorn with INEOS and one with United Utilities in Bootle, I think.
Right.
They're also going to be supervised by our graduates, also class of 2018. And they're not going to come to Liverpool for their weekly, come to the university for their weekly supervisions. They're going to do it over Teams. So you're right. The pandemic has forced many changes that I think some of which will endure. And I think this is one of them. And it does make this more of a likely possibility, really.
Yeah, because people wouldn't have been able to see the possibility of it before. It would have been a difficult prospect to get their heads around. But now it's become the norm. Yeah, I can really see it working. And that's another little Formula One link, isn't it? INEOS, because they are big sponsors of the Mercedes team. So I guess there's more links to this than we realised.
INEOS used to sponsor our velocipede. They paid for us to take it to Nevada for a couple of years. And they take a lot of our graduates. Yeah, so it's a good hookup. And United Utilities, of course, a strategic partner of the university, I think, and they take a lot of our graduates as well. So that was just us making 2 or 3 phone calls to our graduates that we know well because they did on this module a few years ago. They took it to their managers and they said, yep, go ahead. There's another reason that they like the graduates are all on graduate programs. They've got CPD requirements they need to meet. And supervising these projects allows them to tick several boxes. So so not only do they love coming back and working with students who are a few years behind following them on, they get to complete their CPD and they get early managerial and supervisory responsibility that they wouldn't get within the company.
Yeah.
So it's not been too difficult to sell. And we've only every year we turn out another 60 graduates from this module who all go and work with companies far and wide. And I hope that in future, we'll be able to draw on those and set up new projects to follow on behind. So our ambition in the module is to have the big global sporting competitions, those 2 projects, and then all the others will be industrially supervised in the same way that Siemens was, not just industrial context or authentic problem.
Matt, what's brilliant about talking to you is you are clearly passionate about the student experience, and you're looking for new avenues for your students and trying to develop all the time in terms of what you're offering the students. Can you tell us a bit about what drives you to keep enhancing the work that you're doing?
I think it comes down, I think, from being, ever since I made the switch from technical research into education, I've been surrounded by people from all over the world who have clearly identified a shortcoming in the way we were doing things and are themselves passionate about innovation in a way that enhances the student experience, but in particularly enhances their personal and professional development. So just by being immersed in that world for so long, I've been a CDIO partner since 2003, 17 years now. It's been, I've seen what brilliant things other people do at other places. And I always thought, why can't we do that for our students? So that's one thing that's initiated it really. But then seeing our students, I think perhaps I'm being unfair to our new third years, saying they've just had 2 years degree education. They've learned a lot of stuff, but haven't learned to be able to do much. I think I mentioned us squashing a little bit of their passion and ambition with the lecture-heavy first couple of years. But when they then flourish into these projects, it's one of the most rewarding things to see. Students that also maybe aren't brilliant at exams, but turn out to be absolutely brilliant project workers. They find their feet, they're always driving forward. And coming to a project meeting where the students have been so engaged that they blow you away with the progress they've made in a week and the questions they've got. And you can see them over 2 years go from a university student into a fledgling professional. That's what I want to achieve. And the capstones are the main vehicle of doing that. And I think it's a slight risk in this conversation to just talk about those, because they're 2 modules in the mechanical and industrial design program. There are other modules like that in other parts of the school. But there's also smaller versions of this, of active learning approaches, I guess, or learning activities embedded within what's otherwise a lecture-heavy module. But my colleagues have been really careful to design some activities that allow students to develop some important skills. It could be something as simple as in a lecture theatre, a pair-shared discussion. They're talking about the work, but they're developing communication skills and so on, and confidence, engineering confidence, and so on. So ranging from very simple things in lecture to other out-of-class group work, and there's a whole range of things that all put ticks in boxes against the students' professional development throughout the school. So I know we're here to talk about the capstones mainly, but I think we should always remember that this goes on. The CDIO principles that I discussed right at the start apply in every corner. It's taken 17 years to get it there, but it does. So most of my colleagues are now are committed to delivering more engaging and more rewarding activities.
I'm just going to change lanes slightly from students to the technicians that are involved. Now, you touched on technicians earlier on in the conversation, and it'd be remiss of me in my role of working on the technician commitment if I didn't ask a question specifically around the role that they play in the capstone projects. What do they bring that's what's so different?
Well, they basically cover the shortcomings of academic staff, of which there are many in engineering. If you're going to teach students to be professional engineers, it's a strong argument to say that you yourself should have all the skills and abilities that graduates will need, that you're trying to instill in your students. But academic staff aren't like that. I mean, most of us have had some period in industry, but we certainly haven't got all the skills required to deliver a race car, a world record breaking bike, a wind turbine. So we can bring certain things to the table, and there are big gaps. In the past, our technicians have been a group of men in white and blue coats downstairs in the basement workshop, that when the student project supervised by someone like me needs to make something, they send the drawings down and expect it to come back perfect. And what would normally happen is the technicians would look at the drawings and go, oh, this cannot be made. What a ridiculous thing to design. Typical academics, typical students, if only they'd done this. And we're back to this loop. What we realized is we need to get technicians involved early, from day one, working with our students so that when they're designing widget A to go in the car, it's had this expert manufacturing materials design input right from the start. Makes everything run more smoothly. it's a more accurate reflection of professional engineering life too. So we've been very committed over the last 4 or 5 years of involving technicians in the design and the delivery of all learning experiences. They do many things, not just project work. And it's an important theme that's emerging across the world, actually. So Tony Topping, one of my technician colleagues, is a teaching technician. He's actually supervised one of these capstone projects on his own from start to finish. He set it up, he supervised it. This was one called Supermarket of the Future, where he worked with the Hague University of Applied Science in the Netherlands and Albert Heijn, a Dutch supermarket chain, to develop refillables machines to go in the back of store. So you can imagine there'd be bread in one, there's the bread section, there's the deli, there's the pharmacy, and there'd be a refillables section. So he's run that project from start to finish on his own. That's a technician, not just being involved to support someone like me, doing it for themselves. But so, and then having Tony been so successful in that role, we started to think, actually, we put it out across the UK engineering schools that we should build a network for technicians. One thing academics take for as part of their daily life is collaboration in some form, whether it's just dropping an email to someone who teaches the same course of you somewhere else, or really getting together to develop new things with colleagues. We take in that national and international collaboration as standard. Technicians don't enjoy that, and they could get so much from it. So we decided to set up firstly the National Technicians Network, and we had a meeting at Liverpool pre-pandemic about 3 years ago now, where I think 40 technicians from universities across the country came and met together. They spent half the day themselves working out what they could do together, why they wanted to collaborate, and how they could then how they could better support us, probably moaning quite a bit about how bad we were at certain things. And the academics spent half a day, and then we spent half a day together, and it was fantastic. So we took that idea, Tony and I took it to a meeting of CDIO in Denmark, and we set up the international network. And that was due to meet last summer in Thailand, and it was due to meet this summer in Thailand. It's not. So, but we have great hopes for this partnership between academics and technicians to really make sure that we're working effectively together, and to better recognise the role technicians play in educating the students. As part of the Technicians Charter, I think that's an important commitment.
Well, brilliant. Thank you, Matt. This podcast is called the Developing Practice Podcast, and we like to finish each podcast with 3 or 4 take-home tips that our listeners can reflect on in terms of their own personal practice. So if you can maybe summarise some of what you've said in terms of some tips that we could reflect on in relation to your practice, what would they be?
Well, I think the first principle, over the last 15 years of being involved in this community that are much more about an active and experiential learning approach. Whenever I'm developing a module, I don't start by thinking about what I want students to know at the end of it. I start by thinking about what I want students to be able to do at the end of it, and what kind of experiences I think they should have on their way through. So the first thing I have to do is design within the module a program of activities. Deliver the skills and experience that I think is important. And only after I've got my backbone of the activities in place do I then start to think about what lectures, seminars, briefings I need to plug in around those to give them the knowledge that they need and the instructions that they need to complete the activities. So I guess that's quite obvious when we're talking mainly about projects. I mean, that's the way that runs. But I've used this as a principle in all my modules, converting modules from a series of 24 hours of lectures into one that's more like 8 hours of lectures with a lot of group activity in between. So too often, I think I see modules designed as a series of lectures first, and then a few activities squeezed in at the end, mainly to jazz it up, maybe to improve engagement, but not really properly thought through in terms of the skills learning outcomes. So I think every module should be designed to make its own contribution to the student's personal and professional development, not just their acquisition of knowledge. And I'm going to finish by talking to you about one of my pet hates, which if you broadcast it, it might offend some people, because my pet hate is the concept of a skills module. There are those around the university. I've seen them quite recently. I've seen them win awards recently. But a skills module bolted onto a program somewhere doesn't make sense to me. It suggests that most modules are about knowledge, and students do all their skills development on a Thursday at 3 o'clock or whatever it is, right? And for me, that's totally the wrong way to think about HE. I think personal and professional development needs to be infused, diffused, throughout every single learning experience that students have and not bolted on somewhere else. So the importance of authentic learning experiences in driving student engagement and really enhancing their professional development. So I think I tried to set all my teaching in the real world, make it more authentic, not just projects, but even lecture-based courses and the more traditional types of teaching. So wherever possible, I try and work with external partners to help me set a problem, even if it's just a numerical paper-based problem, but to set one that's real, that's come from a partner company. Sometimes to get people from those companies in to guest lecture or to advise students on their work and give them feedback. So I think that's really important, to make everything as authentic as we can. And the third one is to use our alumni. They're our greatest underused resource. And we've been blown away by how quick they are to agree to do something for us. We've had experiences in the past few years. My colleague Graham Schleyer has overseen a student-led initiative, which was our in-department careers fair, where every stand from all the major companies in the UK was manned by our graduates who now work there, who came back to share their experience of work, tell our students what it's like, and to coach them in how to get from where they are now to that graduate entry point. So that's just one example. We've started to use them in projects. I've described the Siemens capstone project. And I think I said already, our students, it turns out, they really love doing it. It ticks CPD boxes for them, and it gives their company a chance to have a good look at our undergrads in the hope of recruiting them for one day. So my third point is use your alumni, and that has to start while they're still in their final year, I think. So we're starting to think about a program of events that we're going to put on for our students to send them out into the workplace ready to come back to us with ideas of things they can do.
Brilliant. Thanks for your time, Matt. It's been a great conversation. Well, it was great to catch up with Matt and discuss some of the things that he's been doing in the School of Engineering. One of the things that he talked about and really sort of emphasised was those developments of the capstone projects with a view to developing a range of skills in students whilst they're involved in designing and building amazing things. He gave us so many great examples of that, from the tomato farm to the nuclear industry to student F1 and things like that. It was just really, really good to hear.
Yeah, you're right. He talked about those skills and how they equipped students for any job in engineering and in other sectors as well. And I like the way he talked about how he disliked the term soft skills, that actually all the skills that they develop are skills and they're all equal and all required.
Yeah, he did, didn't he? Pick me up on that. And that's fair enough. And something I've thought about that. Yeah, he's right. All skills are skills. So I think I'll be changing the terms I use around that from now on.
Brilliant. He also talked about the students being supervised by a professional engineer from industry, and I thought that was really interesting. He talked about the positive impact that this has had on the student experience and on student outcomes. I also like what he was saying about how it's really working well because the industry supervisors are actually Liverpool alumni, and so they can fully empathise with the students. They can be mentors and role models to help the students become future professionals. Well, if you'd like to take your thinking further, we've added some further resources to the website on a specific podcast reading list, which you can access at liverpool.ac.uk/the-academy/podcast. We also love to hear what you think about each episode, so please do tweet us at LiveUniAcademy, and you can also find us at eLearnerMatt or at Alexandra_Owen on Twitter.
Yeah, and as usual, we're really grateful for those who have taken the time to either rate or review our show in your podcast provider's app. So if you are an Apple user, please do take the time to review our show. And for those listening on YouTube, hit the subscribe button now to be updated on our latest episodes. Bye for now.